learners. Welcome to week 3, lecture 14 of our course Child's Growth and Development. And lecture 14 is, we will going to discuss development of muscle dexterity, coordination, gross and fine motor skills. Concepts we are going to cover are development of muscle dexterity, development of coordination, development of gross and fine motor skills, and there are certain references for your further studies. Dear learners, welcome back to motor development. In our previous lectures, we discussed common motor skills of childhood and conditions that influence the rate of motor development. In today's lecture, 14th lecture, we focus on 4 closely connected aspects. Muscle dexterity, especially hand and finger control. Coordination, how movements become smooth, timed and accurate. And gross and fine motor skills. Motor development is a dynamic and multidimensional process through which children acquire the ability to control and coordinate their bodily movements. The progression of muscle dexterity, gross and fine motor skills, coordination and lateral preferences such as handedness and leg dominance forms the foundation for children's personal, academic and social adjustment. Different motor skills serve different developmental functions. In classical developmental texts, children prioritize learning the motor skills that help them achieve the type of adjustment they desire at a particular stage, whether independence or social acceptance. For example, when children seek independence, they focus on mastering self-help skills such as feeding, dressing, or toileting. When they desire peer acceptance, they invest more effort in group-relevant motor abilities such as ball skills and coordinated play. Motor development involves the progressive refinement of muscular control that supports children's ability to manipulate objects, explore their environment, and perform daily tasks. Muscle dexterity and fine motor skills are crucial for writing, drawing, and sustained attention, and early proficiency predicts later academic achievement. Dexterity improves through neural maturation and active exploration. Gross motor skills such as running, balancing, or throwing depend on large muscle groups and enhance mobility, confidence, and peer interaction, developing through perception action coupling. Fine motor development benefits strongly from enriched environments and practice opportunities those you are giving to the child. Coordination emerges as neural networks, including cerebellar and prefrontal pathways, become more efficient. Handedness and leg dominance reflects hemispheric specialization, whether left hemisphere is more active or right hemisphere is active, and it improves motor efficiency and in some cases language development also. Together, motor skills shape independence, academic readiness, social participation, and overall self-confidence of the child. Development of muscle dexterity. Let's see it in details. Muscle dexterity refers to the increasingly precise, coordinated, and efficient control of voluntary muscles that allows individuals, especially children, to perform fine and complex motor tasks such as grasping, manipulating the tools, writing, drawing, fastening, clothing, and performing intricate hand-finger movements. It represents a key dimension of motor development, emerging from the dynamic interaction between biological maturation and environmental experience. The development of dexterity not only shapes children's physical competence but also strongly influences his or her academic readiness, cognitive processing, and socio-emotional participation. Developmental processes underlying muscle dexterity, its neural foundations, environmental determinants, and its significance for overall growth. Concept and significance of muscle dexterity. Let's see the concept. Muscle dexterity, often discussed under the domain of fine motor development, encompasses the ability to execute small, controlled, and coordinated movements using the intrinsic muscles of the hands and fingers. It involves precision, timing, force calibration, bilateral coordination, and integration of sensory feedback. These abilities emerge gradually from infancy and continue to develop during the early school years as children improve their capacity to manipulate objects, perform self-help tasks, and engage in academic activities. Fine motor skill development is predictive of later cognitive and academic performance. In a longitudinal study, found that children's fine motor proficiency at ages 4 to 5 significantly predicted later literacy and numeracy skills in primary school. This relationship is explained by the interdependence between fine motor skills, working memory, attention, and early handwriting, which forms the basis for written communication and structured learning. The ability to draw shapes, grasp a pencil correctly, and maintain eye-hand coordination supports the transition to formal schooling, where children are required to produce written work, copy from the blackboard, handle learning materials, and sustain task engagement. Thus, muscle dexterity is not merely a physical milestone, it is a foundational skill influencing academic trajectories, classroom participation, and self-confidence of the child. Developmental progression of muscle dexterity. The development of dexterity follows a predictable sequence, though individual differences in rate and proficiency are common. Early infancy is characterized by gross hand movements such as palmar grasp and raking movements. As neural pathways mature and myelination increases, infants begin to demonstrate more differentiated control. Early childhood milestones. Near about 6 to 9 months, infants progress from whole hand grasping to using a radial digital grasp, allowing them to pick up smaller objects. By the age of 9 to 12 months, almost 1 year, the pincer grasp emerges, involving coordinated thumb-index finger opposition, a key indicator of emerging dexterity. During toddlerhood, children refine their ability to stack the blocks, turn pages, feed themselves with utensils, and imitate drawing strokes. These developments reflects increasing specialization and efficiency in prefrontal and cerebellar circuits responsible for planning and coordinating fine motor actions. Preschool to school age. Between ages 3 and 6, dexterity undergoes rapid movement. Children learn to button and unbutton clothes, use of scissors, draw shapes and letters, and manipulate writing tools with increasing precision. Use of sharpeners, erasers. By the early primary grades, most children can control pencil pressure, maintain correct sitting posture, and produce legible handwriting. Children's fine motor integration skills, copying forms, using drawing tools, significantly predicted math achievement, demonstrating the strong interplay between dexterity and early academic competencies. Neural and biological foundations. The development of dexterity is deeply rooted in neurological maturation. The brain regions that play a pivotal role include the motor cortex, cerebellum, basal ganglia, and frontal lobes. These regions progressively specialize through a combination of genetic programming and experience-dependent plasticity. Maturation of neural pathways. Myelination of motor pathways, particularly corticospinal tracts, enables faster and more controlled transmission of motor commands. Synaptic pruning during early childhood leads to more efficient neural connections, allowing for refined, purposeful movements. Emphasize that motor development, including dexterity, is not simply a linear unfolding of predetermined milestones, but a dynamic interaction between the nervous system, the body and the environment. Their research on developmental systems theory suggests that dexterity increases as children explore diverse objects and tasks, forcing the nervous system to constantly adapt and reorganize. Now let's see what is the role of cerebellum and prefrontal cortex. These are the structures in the brain. The cerebellum, responsible for coordination and fine tuning of movement, becomes increasingly specialized during early childhood. The cerebellum's integration with the prefrontal cortex supports planning of sequential actions, error correction, and stabilization of attention, all crucial for dexterous movements like writing or threading beads. Thus, dexterity development reflects broader maturation of cognitive motor networks. Sensory contributions to dexterity. Dexterity is inseparable from sensory processing. To manipulate objects precisely, children rely on tactile feedback, texture, temperature, weight, proprioception, position and movement of limbs, visual feedback, guiding movement, adjusting force. Sensory information enables children to calibrate force, timing, and direction of hand movements. For example, adjusting grip strength to pick up a fragile object requires coordinated multisensory input. Perception action theory argues that children learn about their environment by actively exploring it. Through reaching, grasping, and manipulating, they refine sensory motor loops, strengthening the dexterity. What are the environmental and social influences? While biological maturation sets the foundation, environmental experiences strongly influence dexterity's rate as well as quality. A rich, stimulating environment offers diverse opportunities for practice, experimentation, and mastery of that particular skill. Environmental richness and practice opportunities. Children exposed to activity rich early learning environments where they engaged in cutting, drawing, puzzles, building, and object manipulation exhibited significantly higher fine motor scores compared to peers with limited exposure of all these. Motor skill development, including dexterity, is most sensitive during early childhood because the brain is highly plastic. Its plasticity and elasticity is higher. Structured activities such as Montessori based tasks, manipulative play, and art activities provide repetitive practice that strengthens neural circuits. Here, role of adults and social interaction is also important. Adults influence dexterity by providing appropriate tools at appropriate age like blocks, crayons, and beads. Encouraging autonomous exploration. Let the child do that particular activity. Don't do in school he or she will come first and you made that particular block or item or model for them. Let him or her do the cutting, pasting, and other tasks involved in that particular small project. Demonstrating technique. Example, holding a pencil. Offering scaffolding and positive reinforcement. Vygotskian perspectives highlight that dexterity improves through guided participation. Adults help children operate within their zone of proximal development. We say it ZPD, gradually transferring control from assistance to independence. Influence of cultural and technological factors. Cultural practices shape the type of fine motor tasks children are exposed to. In some cultures, early training in weaving, craft work, or tool use enhances dexterity from a young age. Conversely, modern lifestyle patterns characterized by screen-based activities may limit opportunities for hands-on manipulation, potentially slowing fine motor practice. Studies have reported concerns that excessive touch screen use may diminish children's engagement in traditional manipulative play. Although research is ongoing, experts emphasize balancing digital exposure with activities that strengthen hand muscles and coordination skills. Impact of dexterity on academic and social development. Fine motor skills are linked not only to academic success but also to socio-emotional well-being. Children with poor dexterity often struggle with tasks such as writing, cutting, tying shoes, which can lead to frustration, withdrawn participation, or lowered self-esteem. Now let's see academic achievement. Correlations between fine motor skills and early literacy, letter formation, phonetic spelling, numeracy, drawing shapes, writing numbers, executive functioning, planning, task persistence, classroom engagement. Handwriting fluency is particularly important as children who struggle mechanically may divert cognitive resources from composing and conceptual understanding. Social participation. Dexterity supports participation in play activities such as games, crafts, and construction projects, which promote peer collaboration, working in groups, communication with them, and shared problem solving. Children confident in their motor abilities often engage more actively with peers. What are the challenges in dexterity development? Some children experience delays or difficulties in developing dexterity due to developmental coordination disorder, prematurity or low birth weight, neurological impairments, lack of stimulating environments, poor posture or weak core muscles, limited exposure to manipulative play. Pediatric interventions, occupational therapy, and school-based motor programs can significantly enhance the outcomes. Early identification is crucial to prevent long-term academic and social challenges. Now we will see enhancing muscle dexterity. What are the strategies and recommendations? To facilitate optimal dexterity development at the right time, right age, experts recommend providing diverse manipulative materials, blocks, clay, puzzles, beads, and they are there in the syllabus of your toddlers, KG, kindergarten, UKG, LKG, it's all there in their syllabus also. Encouraging drawing, coloring, folding, and threading activities. Incorporate nature-based play, collecting stones, pebbles, leaves, texture or different leaves. So they learn many things out of collecting leaves and stones, and even throwing stones on ponds. Developing bilateral coordination activities, clapping games, drumming. Ensure adequate physical activity to strengthen core and arm muscles. Reducing excessive screen exposure in early childhood. Give them quality time, interact with them, play with them. This is the role of caretakers and parents. Offering scaffolded guidance for tasks requiring precision. Early childhood classrooms play a pivotal role in implementing such motor enriching practices. The development of muscle dexterity is dynamic. It is multifaceted process shaped by neural maturation, sensory integration, environmental stimulation, and social interaction. Dexterity is deeply connected to academic achievement, cognitive control, social participation, and lifelong skill competence. By understanding its developmental pathways and providing enriched environments, educators and caregivers can significantly enhance children's fine motor abilities, supporting their overall growth and future learning success. Now, after having discussed in details the dexterity, we will see development of coordination. Coordination is a fundamental component of motor development that enables children to execute smooth, efficient, and purposeful movements by organizing multiple body parts into integrated action. It involves the harmonious interaction of muscles, sensory systems, and neural processes, allowing individuals to perform everyday activities such as walking, running, catching, writing, climbing, or participating in sports. Coordination is not a single skill but a composite of motor abilities including balance, timing, sequencing, spatial orientation, bilateral coordination, and rhythm. Its development begins in infancy and continues throughout childhood as children gain increasing mastery over their bodies through maturation, practice, and environmental interaction. Let's see the concept and importance of motor coordination. Motor coordination refers to the controlled and synchronized use of different body parts to achieve a smooth action. It is essential for performing both gross motor tasks, throwing, kicking, skipping, and fine motor tasks, handwriting, drawing, buttoning the clothes. Well coordinated children exhibit better motor competence, which in turn influences their physical activity participation, self-confidence, and long-term health. Motor coordination has significant implications for cognitive development also. The cerebellum, traditionally associated with motor control, is deeply connected with the prefrontal cortex, supporting executive functions such as planning, attention, and working memory. Consequently, coordinated motor activities stimulate neurocognitive development, enabling children to perform academic tasks more effectively. Developmental progression of coordination. How it starts from infancy to childhood. Coordination evolves in predictable stages, each reflecting neurological maturation, experience gained by the child, and task practice. Infancy and toddlerhood. Infants begin with reflexive movements, rooting, grasping, stepping, controlled largely by brainstem mechanisms. As voluntary movement emerges, children gain better head control, rolling ability, and sitting balance. Coordination improves as infants develop perception action coupling, meaning they learn to adjust movement based on sensory feedback. Crawling and early walking mark major milestones where balance, timing, and spatial orientation work together. Early childhood from 3 years to 6 years. This is a rapid growth period for coordination. Children learn to hop, skip, paddle, balance on one foot, and throw or catch with more accuracy. Their ability to coordinate bilateral movements, such as using both hands for building blocks or stabilizing paper or drawing, improves significantly. This stage is characterized by qualitative changes in movement patterns as children transition from immature, stiff movements to more fluid, rhythmic ones. During early childhood, this is a rapid growth period for coordination. Let's see middle childhood now. By this age, coordination becomes refined and increasingly efficient. Children can control force, speed, and direction to perform complex motor tasks, including sports skills like dribbling, batting, or gymnastics. Improvements in neuromuscular control and sensory integration allows them to modulate movements more precisely. That motor coordination during this stage predicts physical activity, engagement. Children with higher coordination are more likely to participate in sports and active play. Neurological foundations of coordination. Coordination is deeply rooted in brain development. It requires efficient interaction between different neural systems controlling movement, balance, and sensory integration. Now let's see what is the role of cerebellum. The cerebellum is the central structure for coordinating the timing, sequencing, and smoothness of movement. That cerebellar development is crucial for error correction, motor planning, and fine-tuning movements, explaining why children gradually move from unsteady to well-coordinated actions. Sensory integration. Motor coordination depends heavily on the integration of information from vision to guide the movement, vestibular systems to maintain the balance, proprioception to sense limb position, tactile feedback to adjust force as well as grip. These systems work together to provide constant feedback about body position in space. That motor development is an adaptive process where children refine movement strategies through continuous sensory feedback and exploration. Now we will see maturation of neural pathways. Myelination of motor tracts enhances the speed and accuracy of neuronal communication. Synaptic pruning increases efficiency by eliminating unnecessary connections, producing more refined coordination. This neurobiological maturation supports improved timing, balance, and complex motor sequencing. Let's see what are the environmental and experiential influences. While heredity and neural maturation provide the foundation, environmental experiences significantly shape the quality of coordination. Practice and repetition. Motor coordination improves through repeated practice. The more children engage in diverse physical activities like running, jumping, climbing, ball games, the stronger their motor competence becomes. Structured motor skill practice significantly enhance coordination and motor efficiency. Enriched environments. Children with access to playgrounds, open spaces, sports equipment, and manipulative development develop coordination more rapidly. Enriched preschool settings where children engage in active movement lead to improved fine and gross motor outcomes. Now let's see what are the types of coordination. Motor coordination includes multiple subcomponents. First is bilateral coordination, using both sides of the body simultaneously. Example, climbing, cutting, catching. Bilateral integration strengthens midline crossing and brain hemispheric communication. Hand-eye coordination or eye-hand coordination, aligning visual information with hand movements, essential for writing, drawing, catching, and using tools. Balance and postural control, maintaining center of gravity during static and dynamic activities. Vestibular development plays a major role in this process. Timing and rhythm, coordinating movement sequences in time with external or internal cues, enabling activities such as dancing, skipping the rope, and sports. What are the challenges which affect coordination development? Some children display coordination difficulties due to developmental coordination disorder, neurological delays, sensory processing dysfunction, prematurity, limited movement experiences, sedentary lifestyle of that particular family or the child. Children with DCD often struggle with academic tasks like writing, cutting, as well as playground activities, affecting self-esteem. Early identification and targeted intervention improve the outcomes. How to enhance motor coordination? Effective strategies include obstacle courses, throwing and catching games, balancing activities, rhythmic movement and dance, playground climbing, yoga and core strengthening, fine motor stations like puzzles and beads. Programs integrating structured motor activities significantly enhance coordination and academic readiness. Coordination in motor development is dynamic, multifactorial process shaped by neural maturation, sensory integration, and environmental experience. It involves progressively from basic reflexes to complex, skillful movements necessary for daily functioning, academic success, and social participation. Now we will discuss development of gross and fine motor skills. Motor development refers to the progressive acquisition of movement skills that enable children to interact with and adapt to their environment. Within this domain, gross motor skills and fine motor skills form two essential and interconnected components. Gross motor skills involve large muscle activities such as walking, running, balancing, jumping, and throwing, while fine motor skills involve smaller, more precise movements of the hands and fingers used for grasping, writing, drawing, buttoning, and tool manipulation. The development of these skills reflects the interaction between neural maturation, physical growth, and environmental experiences. Let's discuss development of gross motor skills. Gross motor development begins early in infancy as children gain control over head and trunk movements. The progression typically follows a cephalocaudal and proximodistal pattern. Initially, infants develop head control, followed by rolling, sitting, crawling, and eventually walking. These early milestones depend on increasing muscle strength, postural stability, and coordination. There is a theory behind this, perception action theory. It emphasizes that gross motor skills develop as children actively explore and adapt to their surroundings. For example, infants learn to adjust their gait and balance by receiving sensory feedback from surfaces, objects, and spatial layouts. As children move into early childhood, gross motor skills become more refined with improved balance, speed, agility, and rhythm. Activities such as climbing, hopping, paddling, kicking, and throwing become smoother as neuromuscular control strengthens. During middle childhood, gross motor coordination becomes increasingly efficient. Children, they engage in structured sports that require timings, precision, and complex skill combinations. A developmental model linking motor competence to physical activity, children with higher gross motor proficiency are more likely to maintain active lifestyles. They participate in sports and develop healthy fitness patterns. Environmental experiences strongly influence gross motor movements. Development. Access to playgrounds, open spaces, and physical education opportunities enhances children's motor competence. Structured motor skill interventions significantly improve children's fundamental gross motor abilities such as jumping, running, and object control. Now, after having done this gross motor development, we will do development of fine motor skills. Fine motor skills involve precise control of small muscle groups, particularly in the hands, fingers, and wrist. These skills are essential for manipulating objects, writing, drawing, dressing, and engaging in self-care tasks. Fine motor development follows a general to specific pattern. Young infants use whole hand grasps before gradually progressing to refined fine finger movements. A critical milestone in infancy is the development of the pincer grasp, thumb index finger opposition, which typically emerges around 9 to 12 months. This ability marks the beginning of controlled object manipulation. As children grow, fine motor skills advance toward greater efficiency, accuracy, and speed. By preschool age, children develop the ability to draw basic shapes, use utensils, stack small objects, and participate in craft activities. Neural maturation plays a major role. The development of the cerebellum and prefrontal cortex supports improved fine motor control, coordination, and executive functioning. These neural changes allow children to plan the actions, regulate movements, and maintain attention for fine motor tasks such as writing or using tools. Fine motor skills are particularly sensitive to environmental enrichment. Preschool children who engaged frequently in fine motor activities like cutting, drawing, bead threading, using blocks displayed significantly stronger academic skills in kindergarten. Now let's see the relationship between gross and fine motor development. Although gross and fine motor skills are often discussed separately, they develop in interconnected ways. Gross motor competence provides the physical foundation for fine motor tasks by strengthening core stability, posture, and neuromuscular control. For example, a child must maintain stable shoulder and trunk posture to produce controlled handwriting or drawing movements. Conversely, fine motor activities often enhance visual motor integration, spatial awareness, and cognitive control, which indirectly support gross motor performance. Early motor development, including both gross and fine motor milestones, predicts later cognitive and academic outcomes. This underscores the holistic nature of motor development. Motor proficiency influences not only physical abilities but also overall developmental trajectories. Environmental, social, and cultural influences. Motor development is shaped heavily by environmental opportunities and cultural practices. Children raised in environments rich in motor opportunities tend to exhibit stronger gross and fine motor skills. Social interaction, guided practice, and adult scaffolding also contribute significantly. Vygotskian perspectives emphasize that children learn new skills within the social context, with adults demonstrating and supporting motor tasks such as writing, catching, or cutting. Modern technological environments offer advantages and challenges. While digital tools may support some types of visual motor coordination, excessive screen time can reduce engagement in hands-on manipulative play, potentially limiting fine motor experiences. Balanced exposure is therefore essential. Developmental challenges and interventions. Some children experience difficulties due to developmental coordination disorder, neurological conditions, or limited exposure to motor-rich environments. Children with DCD often struggle with handwriting, ball skills, and balance, affecting both academic and social participation. Early identification and intervention such as occupational therapy, motor skill training, and structured play significantly enhance outcomes. Interventions that integrate play-based activities, obstacle courses, fine motor stations, and multisensory tasks have been shown to strengthen motor skills across domains. Schools and early childhood programs play a critical role in providing supportive environments for motor growth. Gross and fine motor skills are foundational components of motor development, emerging from the dynamic interaction between biological maturation, sensory feedback, environmental experiences, and social guidance. Gross motor skills support mobility, balance, and physical fitness, while fine motor skills enable precision, object manipulation, and academic readiness. Both domains contribute significantly to cognitive functioning of the child, school achievement, and social participation. Finally, we can conclude this particular lecture: motor development is a holistic, dynamic process in which muscle dexterity, coordination, and gross and fine motor skills evolve through the combined influence of neural maturation, sensory integration, and enriched environmental experiences. These skills lay the foundation for children's independence, academic readiness, and social competence. Muscle dexterity supports precision, tasks such as writing and tool use, while coordination enables fluid, controlled movement essential for daily functioning and physical activity. Gross motor abilities enhance mobility and confidence of the child, whereas fine motor skills strengthen their cognitive and academic performance. Early practice, guided participation, involvement of the parents and teachers, stimulating environments accelerate the motor proficiency. Supporting children with diverse motor experiences and timely interventions ensures healthy development and lifelong benefits. There are certain references for your further studies. Thank you and happy learning.